Hey guys, this is T here. It's another video. This one's on Pythagoras Theorem and using it with a Cartesian plane. So, a right angled triangle, this is all about right angled triangles, is a triangle that's got a right angle as one of its angles. A right angle is 90 degrees, so a square angle. Below are some examples of right angled triangles, so you can have the right angle pointing up, down, down again, different orientation. The longest side of a right angled triangle is always opposite or across from the right angle. So you can see that here, the longest side, it is across from the right angle. The longest side of this triangle is across from the right angle. Longest side across from the right angle. The longest side has a special name, the hypotenuse. Now, Pythagoras was an ancient mathematician. He found a special relationship between the length of all of the three sides in a right angled triangle. That relationship we now know as Pythagoras Theorem. So, what's Pythagoras Theorem? Here's a right angled triangle. I've named the hypotenuse C. The other two sides are A and B. So his theorem is that in a right angled triangle, and with the hypotenuse that we've called C and the other sides A and B, C squared, the length of C squared, the hypotenuse, is equal to the length of A squared plus the length of B squared. So, in other words, if I worded that as a sentence, the length of the hypotenuse squared is the sum of the square of the other two sides. So you square the other two sides, add them together, and they will add up to the square of the hypotenuse. So let's do an example here. Find the length of the hypotenuse of the following right angled triangle. So here we have a right angled triangle with one side 4 centimeters, the other side 6 centimeters, and we're trying to find the hypotenuse. So the hypotenuse, we'll call it C squared, is going to be the same as A squared, or 4 squared, is one of the sides plus the other side squared, which is 6. So I still don't know what C is, so leave that. What's 4 squared? We know what that is. That's 16. 4 times 4 plus. We know what 6 squared is. That's 36. So right now I'm just going to grab my calculator. Put in everything, or find out everything we do know. 16 plus 36. That comes to 52. Now we know from algebra that we want to find out what C is itself, so we need to do the opposite of what's being done to C. What's being done to C? It's being squared. So you need to find on your calculator now, you may never have done this before, the opposite of squaring something. So squaring something is timesing by itself. The opposite of squaring something is finding the number that you have to square to get this number here. So you do that on your calculator. You're not going to be asked to do that in your head. You can if you want to for simple ones, but you need to find the square root button. It looks like this on the graphics, on your calculator, sorry. And then square root this number to find what C is. So if I do that on my calculator, I do square root of 52. That tells me 7.21, and that's to 2 decimal places. That's telling me that 7.21 is what I times together to get 52, and that's how long the hypotenuse is. So the hypotenuse here, if you've got a right angled triangle with 4 centimeter side, 6 centimeter side, the hypotenuse is going to be 7.21 centimeters long. So what does this have to do with the Cartesian plane? This theorem is useful in coordinate geometry when finding the distance between 2 points, because if the points are positioned diagonally, they actually form corners on a right angled triangle. So for example, if you're asked to find the distance between the points from last video, B, -2, 3, and A, 4, 2, if I was to draw lines down and across from the 2 points, you'll see that there is a right angled triangle. Okay, and so the length of this side is going to be, well, how many steps has it gone up from the bottom of the triangle? It's 1. How many steps is it along the bottom? 1, 2, 3, 4, 5, 6 steps across. So what you end up with is a triangle that looks like that. 1, 6. And we can use Pythagoras' theorem to find how long that distance is directly from B to A, because they're on the corners. Okay, so let's use Pythagoras' theorem for that. Let's call that distance C again. So C squared is going to be this side 1 squared plus the bottom 6 squared. C squared is going to be, what's 1 squared? 1 plus, what's 6 squared? 36. C squared is going to be 1 plus 36, 37. The opposite of squaring something is square root. So square root of 37, so you need to use your calculator for this. Square root of 37 is 6.08 to 2 decimal places. So that is the distance between B and A. Now, I just wanted to do a quick demonstration of, let's say you had 2 points that were on the same line, like that. And that doesn't form a triangle, but you're still asked to find the distance between them. Let's call these points, say, X and Y. X's coordinates are 4, 1, 2, 3, 4, 5, 6, 7. 4, 7, and Y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 7. We can't actually draw a triangle there, so you have what's meant to be a triangle, but looks like this. And it's X and Y. And it is 6 long. You can't really chuck it into this formula because it's not a triangle with multiple sides, but you do know that one of the sides is there. So let's say that C squared is equal to, we don't have a side A and a B, we've only got one of the sides, so C squared is just going to be that side that we know, which is 6. So C squared is equal to 6 squared, which is 36, and then in your calculator, you might be able to do it in your head. What number can you times together to make 36? But if you need it on your calculator, do square root of 36, and you'll get that C is 6, which is kind of obvious because this line is 6 long. So if you can see that already in your head when you've done it, it's a straight line up or down, or a straight line across. The distance between the 2 points is just how far those points are away from each other. You don't really need to do this Pythagoras stuff, but it's good practice anyway to do that. So that is showing how Pythagoras is used on the Cartesian plane. Hopefully that helps you out, and I'll see you in the next video.